In the previous two lectures, we have seen the basic properties and fundamentals related to geometry. Now in this session, what we are going to do is all the questions which are asked in the previous papers, I'll be taking out. So we will try to solve those questions, and also we will try to predict some questions which can be asked based on the previous patterns. Okay. So I'll take around 3 sessions for solving these questions. With that, geometry will be complete for any exam if you take, not just at CAT level. Okay, so we'll be looking at a very higher level, and if you're taking any exam, it is going to be very easy for you. Okay, so let me give you a very simple question to start with. Now this was the question which was asked in 2001. You can start solving this. Take 1 minute and you can solve it. You pause the video and try to attempt this question. Now how will you solve this question? See, this is a very easy question and everybody will solve this question. Okay, so I'm sure everybody will solve this question, but if you solve this question, you should solve it faster, and that's where you get the advantage. Otherwise, solving this question is not going to make any difference, because everybody is going to solve this question. Now how will you solve faster? That's what I'm going to discuss. Otherwise, see, solving this question is anyway going to be easy for you. There is no fun in discussing that. Okay, how can you solve faster is what we need to discuss here. What is given? These three are equal, right? AE and EF and FB are equal, and we need to see the ratio between the total, that is the rectangle, and the triangle CEF, right? That ratio is what we need to find out. Now, if it is a question based on area, and I will tell you, area based questions are going to be very easy in geometry. If it comes, you should attempt, and it is not based on any formula. You can just solve by using common sense, just by cutting the diagram. And most of the area based question, you can cut the diagram and you can get the answer faster. Okay, so let's see how you're going to cut this diagram. See, first of all, you divide this diagram into 2. Okay, so I'll make a division like this. Now I have divided this into 2. Okay, now I can see three triangles in the bottom, right? So I have dropped the diagonal, so that diagonal divided this rectangle, so I can see 3 triangles. Now in the other portion also, can I make the same 3 triangles? Is what you need to look for. One thing is sure, these 3 are equal. So let's take the same length here, and here. Let's take the same length. So you can exactly make a replica of what is given here. So how many areas are there in total now? How many triangles are there? 6 triangles are there. So this bigger rectangle which is given is actually comprised of 6 triangles, and out of that they are asking you about this. So it is actually 1 by 6. No need to use any formula, no need to think too much. Okay, just cut the diagram, whatever is there in the bottom, make a replica of that in the top, so that it is crystal clear that there are 6 triangles in the rectangle, and out of that 6 triangle, about 1 triangle is what they are asking, and the ratio is going to be 1:6 or 1 by 6, and I'll pick this as a correct answer. I hope this is clear for you. What I have done, I just cut the diagram. How I cut the diagram? I cut this into 2 equal parts. Okay, by using the diagonal. So the diagonal divide the rectangle equally into 2 triangles, and in the bottom, in the triangle, I got 3 small triangles. In the same way, I can make a replica in the top. So effectively, that rectangle comprised of 6 triangles, and out of that, about 1 is what asked. So once you came to know that 6 equal triangles are there, this is going to be very easy, right? Out of 6, 1, that means 1 by 6 is the answer. Now similar patterns have asked in a lot of papers. You can see, okay, if you want one more question, see, let me give you this question. Okay, again, take a pause and solve this question in 1 minute. You see, I tell you, it is not even required 1 minute. Hardly you need 10 seconds to solve this question. And if you are attempting this question, everybody is going to solve this for sure. But if you solve it, you should solve it in 10-15 seconds. Now how will you proceed? See, the answer, it is very easy. It is actually 1 by 12. All of you know this. But how you are getting this 1 by 12? How will you cut the diagram? See, the idea is, this is the hexagon, right? So a hexagon, basically, if this is a center, it comprises of 6 equilateral triangles, right? So a hexagon, a 6 equilateral triangle. Now, what is happening here is, this triangle is divided by using that. So Now if you drop this, it will come like this. That's actually a diagonal of this quadrilateral. If you mark this as AOEF, that is a quadrilateral divided by the diagonal. So you can make divisions like this now. Okay, now this is crystal clear. You can see 1 2 3 4 5 6 triangles, equal triangles on the top, and similarly 6 equal triangles on the bottom. So how many triangles are there? 12 triangles are there. So that hexagon comprises of 12 triangles. Out of that, they are asking about this small triangle, right? Then what is your answer? 1 by 12. 1 by 12. So see, if they are giving you a hexagon like this, they can ask you a lot of questions. Okay, I have seen in a previous paper, this two sides are shaded. Okay, then they will ask you what is the ratio between the total hexagon and the shaded region. So how will you find it? Again, there is no formula you need to use here. You just need to use common sense. Cut the diagram accordingly or arrange the diagram accordingly. See, a hexagon, the fundamental thing that you need to know is, this is a hexagon, right? The divisions that you can make. Okay, so firstly, the same thing that I have shown you already. You have 6 equilateral triangles. So one hexagon, 6 equilateral triangle. So I can make a question just like this. I will make this shaded region and I can open this out like this. Okay, then I can ask you the ratio. Then what is your answer? Out of 6 triangles, 2 are shaded, right? 2 are shaded, so 2 by 6, that means 1 by 3 is the answer. In this case, 1 by 3 is the answer. Now why it is 1 by 3? It is actually, you have 6 triangles in a hexagon. Okay, like this. You have 6 triangles in a hexagon. And what I have done is, I can take this out. Okay, let me take this from the 2 triangle. I am taking that center line out. Okay, then here also I do the same thing, and here also I do the same thing. So effectively what I am doing is, I am combining the 2 triangles. I am combining the 2 equilateral triangles, right? So what I am getting here, I am getting 3 quadrilaterals, and all the sides are equal, so you can say 3 rhombus you are getting. This is parallel. Okay, both are parallel and all are equal. Why it is equal? Because these all are the sides of equilateral triangle, and we know all these are equal. Now how can you solve this question? This question how can you solve? You can take out this portion and just stack it with this. Okay, so it will look like this. If you take that portion, it will look like this, like this. So it is actually 1 by 3. So this portion, if you bring it to this part, okay, keeping aside this rectangle away, okay, it will be like you can keep that rectangle outside. Just take this point and flip it over and attach with this. It will look like this. So your answer is 1 by 3. Or what you can do, or see, otherwise you don't want to think in this way also. This is the hexagon which is given, right? So this is shaded and this is shaded. And we know this is actually 6 equilateral triangle, right? So I have 6 equilateral triangle now. Now you can drop this line. Okay, so 1 2 3 4 5 6 on top, 1 2 3 4 5 6 again on the bottom. So 12. Out of that 12, here is 2, here is 2. So total 4. 4 are shaded, so your answer is again 1 by 3. So you can divide into 12 equal triangles, and out of that 4 are shaded, so 4 by 12. Or you can think in this way also. Take this portion and attach with this, so it will look like this. Okay, now other way in which you can get a question from hexagon. See, we are looking at different possibilities. I promised you by the end of the session you will be in a position to predict questions, right? See, like this, if you get a question like this, okay, this is A, B, C, D, E, F is the hexagon. Okay, what I'll ask you is the ratio of A, C, E, that is a triangle, divided by A, B, C, D, E, F, that is the hexagon. What is the ratio? How can you find it? See, without using any pen on any formula, how can you find it? This is a midpoint. And we know this is how you can divide. This is how you can divide. So we know a hexagon is actually comprised of 3 quadrilateral or 3 rhombus, right? So 6 equilateral triangle, and if you remove the, see, this is actually an equilateral triangle. We are removing that diagonal, right? Okay, so what is the answer? See, this one with this line you are actually dividing into 2. So these two are equal areas. Now these are equal, these are equal. So 6 equal areas are there. 6 equal triangles are there. Out of that, how many is shaded? 1, 2, 3. So big triangle comprised of 3 triangle and the hexagon comprised of 6 triangles. So hexagon to the triangle ratio will be 3 by 6, which is nothing but 1 by 2. Why 1 by 2? Because if you see in all cases, these are diagonals and dividing equally. So 1, 1, 1, 1, 1, 1. 6 equal areas. Out of that, if you want to shade, 3 are shaded. So shaded region is 3 out of 6. So 1 by 2 is the ratio. See, now I can ask you this hexagon like this. It can be divided into 6 equal areas. That you understood. Then if I take this out, what I'll get? I'll get 3 quadrilateral or like 3 equal ones, right? So rhombus, 3 rhombus. So one rhombus is actually 2 equilateral triangle combined. Okay. Now here what question I made is, I divided like this, I divided like this, I divided like this. Then I asked you this question. Now see again, what is the maximum division you can make? From the 6 equilateral triangle, take 1. Then you can further divide, right? You can further divide a triangle like this. All these are again equilateral triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for every equilateral triangle, you can further divide into 9 triangle. So 6 equilateral triangles are there. So 9 into 6, 54. Further divisions you can make, but you won't get questions at this level. But this is the maximum you can expect, right? Now if I give you one more question, let's take a question like this. Okay, let me take this as P, Q, R, S. Okay, now the midpoint of PQ is A and midpoint of QR is B. I'm joining these two midpoints, okay, and extending it to C and making a triangle. Then I will shade this triangle, and then what I'll ask you is, I'll ask you ABS divided by PQRS. So effectively what I'm asking is the ratio between the triangle to the rectangle or the square. What is your answer? So assume that this total area is 100. Okay. Now that's not required because we are not expecting in terms of percentage or anything. Whatever it is, if it is 1, we will consider in that way. If it is 100, we will take it in that way. Okay. Or the area might be given. Let's see what is the fraction or what is the ratio here. So then they will, if they give you one side is 16, we know the total area is 256. Then if we know what percentage of 256 is this triangle, we can find the area of the triangle, right? So let's find it out. So let's assume that the total is 100. Let's assume that for time being total area, that means the square is 100. Okay. Now let's see how much is the triangle. So what you can do is, see, the simple idea is, if you can get the area of this 3 outer regions, 3 outer triangles, and the total we assume that it is 100. So if you subtract the outer areas, you can get the area of the inner triangle, right? So let's find the outer areas. Now the square total area is 100 means if you take half of it, it will be 50, right? So if I consider the bottom portion, that is BRQS, if you want you can mark it as B dash. So B dash BRS, that is a bottom rectangle, that is 50. But if you observe here, by using this diagonal, that 50 is divided into 2, right? So this is going to be 25. So I got one outer area, 25. Similarly, I can find the other two also. Basically what I need to do is, let me drop another line here. Let me make a division like this. I have made a division. So let me mark it as A dash. So A dash SP, this left side rectangle, if you take, that is half of the square, that is also 50. And by using this diagonal AS, that rectangle is divided equally, so this is also going to be 25. So if the total is 100, this has to be 25. Now what is left out? The small triangle AQB is left out, right? So how will I find the area of that outer area? For that, I don't want to take the complete square. I don't even want the half of the square. I can take this quarter alone. So what is the quarter of the square? So if total is 100, that will be 25. Then by using this diagonal AB, it is divided equally. So what is the outer area? This will be 12.5. So we got the outer areas, right? One is 25, the other is 25, and one is 12.5. So what is the total outer area? 62.5 is the total outer area. So what is the area of the triangle? That is going to be 100 minus 62.5. That is 37.5. If it is 100, 37.5 is the area. If it is something else, 37.5% is the area. Because effectively you are writing 37.5 by 100 is the ratio, right? So this is nothing but percentage. See, this is a fraction, and if the denominator of the fraction is 100, that is percentage. So percentage is a special case of fraction where the denominator is 100. So here it is 100. So we have taken it as 100 to make it as 100 to make it as percentage. So if they are saying one side is 16, when a total area is 256, what is the area of the triangle? Without knowing any sides, I can find just by taking 37.5% of the 256. Otherwise, you know what the students will do? The moment you see this kind of question, right? See, you will see this kind of question. This is 16. One side is given. So what you will generally do is, so this side is 16, and the moment I tell you these are midpoints, I mark it as 8, 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 and this is 16. So if you look this 8 and 16, okay? So by using the Pythagoras formula, you will get this side. Then here also you apply the same, you get this side. Then you use this side. And then you will use the formula to find the area, root of s into s minus a into s minus b into s minus c. But that's not worth. So this is how you need to solve. Okay. Now if you need to see one more question, I give you one more question.